Hey there, hello everyone, welcome to the another video of mine. In today's video, we'll be discussing on merge case sorted and list. So in this video, we'll be mainly focusing on these topics, and we'll be also learning what is it and how is it used, and some various other factors of the merge case sorted list. So as you can see, we all know that we compare different approaches, analyze their complexities and implement efficient solutions. So using a mini heap. So in this algorithm we also use something like a different approach that is called as a brute force approach. So what you do in a brute force approach is nothing but it involves merging the list pairwise until only one list remains. So as you can see in the image beside, we got the array. It can be like 1 5 3 4 2 6. So this is what you have got here. So let me explain it with a proper sketch. So this is what we have got here. So then this part will be splitting into two different parts. So when we split this, we'll be getting 1 5 3 and 4 2 6 as a two separate parts. So then what we are doing is splitting it again. So can we split it again? Of course we can. So we can split 1 5 and 3 one time, and we can also split 4 2 and 6. So what we need to do is again we need to try splitting each of them. So when we try to split each of them, we'll be ending up with 1 5 3 4 2 6, all with having their own separate values. So now again what we need to do is merging. As you can see, the brute force approach involves merging the list pairwise. So as you can see, brute force approach includes merging the list pairwise until only one list is remaining. So as you can see, the method has a time complexity of O n k log k, where the n is the average length of each list and k is the number of lists. So we have seen this and we have an idea now. So what we need to do, we need to merge the list pairwise here. So we can pair 1 and 5 here, 3 we have 4 and 2 and 6. So these are the values we have paired here, and we have also paired here. So when we pair them, we will be knowing in what order they have. So we'll be arranging in the ascending order. So if our previous value is less than the current value what we are having, then we'll simply replace. As you can see, at first we had 5, then we had 3. So what we basically did is extended the value of 5 with 3. So now similarly, as you can see here, we are having 2, 4 and 6. So what we did is we had 4, 2 and 6. Since our 2, which was the least value or the lesser value than 4, we have replaced it. And now we are having 1, 2, 3, 4, 5, 6. So this is a final list what we are obtaining after sorting of all the elements in the array. So now let's discuss about the efficient approach using a min heap. So a min heap allows to efficiently extract the smallest element from a set of sorted lists. So let us go through this in a proper in-depth manner. So we iterate all the list, adding the first element to each of the heap. So what we do is we perform 3 operations here, that is initialization, extraction and repeat. So in initialization, what we basically do is we add the first element from each list to the heap. Then we perform the extraction process. So in the extraction process, basically what we do, so they extract the minimum element from the heap and add it to the next element from the corresponding list. So then what we do, we have the repeat process. So in the repeat process, basically we keep on repeating the same process continuously, so until our list elements are empty. So as you can see, we have performed a basic min heap operation. So we get started like this. Let me clear this off. Yeah. So this is how we write. We go in order like this, in a step-by-step manner, in a list for the order of our array. So when we follow this approach, we will be ending up in a structure or a mini heap tree like this. At first we got the 2, then we got 3, then we have 8. Then next we will go to the 4, then we have the 7, then we have the 10, then we have 9. Similarly we have 15, 9, 13, 9, 20 and 19. So this is how basically we perform a min heap operation. Next thing we need to discuss about is time and space complexity of the min heap solution. So the time complexity of the min heap solution is O n log k, where n is the total number of elements in our list and k is the number of lists. So the space complexity is O of k for storing the heap. So the different operations, what you can do is something like time complexity. The different operations, what you can do is inserting into the heap is one of the operation, and extraction of the min from the heap is another operation what you can do. And the time complexity, if you want to insert into a heap, there will be O log k, and the time complexity for extracting the min from the heap will be O log of k. Then next, head to our next topic, that is comparison with other solutions. So the min heap solution is more efficient, and the brute force approach basically, especially because it is larger value of k. So other solutions like the divide and conquer or using a priority queue can be considered, but the min heap solution offers a good balance of performance and simplicity, what you can say. So in the brute force we have a time complexity of O n k log k, then the space complexity of O of 1, then similarly we have the min heap. For the min heap, time complexity is big O n log k, and the space complexity is big O of k. Then we have the divide and conquer. In divide and conquer we are having time complexity of O n log k and space complexity of O of n. So that's it guys, that's it for this video. See you in the next video. Make sure if you like the video and subscribe. Thanks.